Okay, so this is the part which we have covered, right? So it had some decent, I mean, mostly medium questions. Then there are a couple of hard questions, not a lot, right? Cool, cool. Sounds good. So for today's class, we are going to start with the recursion and backtracking. Okay. Chali, let's get started. So in today's class, as I told you, we'll be working on recursion and backtracking, right? So just a sec. Chali, let's get started. So again, our approach will be question based, right? But before starting the recursion based question, right? Before starting the recursion based question, I want to tell you guys one thing, okay? And that is, whenever you're solving recursion questions, it always comes down to two things, right? It always comes down to two things. First thing is the base condition. Shoot, why is my writing bad? Just a sec. Okay, now it will give me more control. Yes. So first thing is the base condition, and the second thing is the next recursion, right? So you keep thinking that now that I'm in this function, where else do I have to go, right? So these are the two conditions. So you check the base condition, you also check the terminal conditions here, right? And then you go to the next step, which is from here, from this point onwards, in which direction can I go? Which function should I move to, right? So these are the two base things which we'll be working on, right? So in today's class, let's get started with a simple, easy question. Which one should I pick? Okay, let's pick this one. It's a simple and very easy. Oh shoot! It's a simple and a very easy problem, which I'm gonna start with, right? First is an easy medium problem. The problem is called permute. The problem is called permute. Or instead of permute, let's start with an easy interactive one. Okay, it's called generate parentheses. I'm sure you guys have heard of this one, but if not, no problems. Okay, so this problem is called generate parentheses. What generate parentheses means is that in the input, when you will be given an input, you'll be given a number n, right? And n belongs to an integer. Integer can be not just any integer, it's a positive integer. So it can be 0, 1, 2, and so on, up to any number, right? And the output will contain all the balance parentheses in which we have n number of opening parentheses and n number of closing parentheses. What I mean by that is, for example, n is equals to 2, right? If n is equals to 2, what are the number of balanced parentheses which has 2 opening parentheses and 2 closing parentheses? For example, this is a possible answer and this is a possible answer, correct? See, for n is equals to 2, I can see that these two are the solution, right? Is there any other solution available apart from this one? Maybe not, I'm not sure. But this is one of the solution for n is equals to 2. And this is also one of the solution for n is equals to 2. Now, when I give you an input n, I expect you to return me a vector of strings, right? A vector of string which contain all the possible combination we can have for n is equals to 2. Is that clear? So again, let me rephrase the question. You'll be given a value n, right? And I want you to return me a vector of string which contain all possible combination of this particular balanced parenthesis scheme, given that it satisfies this value n, correct? So we're going to get started with this problem. Let's get started. So assume that at any point of time you have number of opening parentheses. I'm going to start with 3. A number of closing parentheses. I'm going to start with 3. Okay. So the final solution which I'm going to create, how many characters will it have? It will have 6 characters, correct? 0, 1, 2, 3, 4, 5. It will have 6 characters, correct? 3 opening parentheses and 3 closing parentheses. So first, let's think about filling the first position. What can be the value here? It can be an opening parenthesis or it can be a closing parenthesis, correct? let's say I do both the values, right? Let's say I do both the values. If I use an opening parentheses, how many opening parentheses am I left with? 2, closing parentheses 3. Opening parentheses 3, closing parentheses 2, right? From here, I'm going to look for the second position, second element, right? So first is already set. Now second position can be either an opening parentheses or a closing parentheses. Is that right? So at this point of time, the number of opening parentheses I have is 1. Number of closing parentheses I have is still 3. In this case, number of opening parentheses are 2, and number of closing parentheses are also 2. Now come back to this particular case. In this condition, in this particular instance, the number of opening parentheses I have has become more than the number of closing parentheses, right? And if you have used more closing parentheses as compared to opening parentheses, what does that tell you? What's the meaning of this? That means the combination you have created is an unbalanced one, right? The only reason this condition has come is when you have created an unbalanced string. For example, this, if I just take this into consideration, this one is an unbalanced this one is an unbalanced string, right? This is not balanced. So we'll not proceed from here. We'll stop. Let's move to the next iteration, right? If I move to the next iteration, what is the next value? It can be an opening parentheses or it can be a closing parentheses. In this case, how many opening? How many closing? How many opening? Oh, shoot. How many closing? Similarly, for this one again, I'm going to create 2 cases, right? Either it can be open or it can be closed. If it is open, how many open I have? 1. How many close I have? 2 left. In this, how many open I have? 2. How many close I have? 1, right? Again, look at this particular condition, my friends. This particular case. What does this mean? This means that I have created an unbalanced string. I mean, this is not a valid parentheses string, right? So I'm not going to proceed further from there. And I'm going to keep moving further, keep adding either an opening parenthesis or a closing parenthesis this way. And I'll keep on doing that, right? So this is how I'm going to approach this problem. Now, when you talk about recursive problems, right? When you talk about recursive problems, you have to make sure that, I mean, of course, recursive problems generally go into polynomial exponential time, correct? But you have to make sure that you keep on optimizing it so that it does not go that way, okay? So we'll try to write a code in a manner that it does not affect a program. I mean, that's how the intention is going to be, right? So let's get started. Writing a recursive code that is good looking is not very difficult as long as you just keep on practicing. Recursion requires practice. If you understand recursion properly, you'll understand trees, you'll understand graphs, you'll understand all the different hierarchical data structures, okay? So what I said, I'm going to return a vector of string, right? Let's call it generate parentheses. And in the parentheses, what's going to be the input? Int n, right? Since I'm not going to be changing this value, I can make it constant, correct? Now, let's write a helper function which can help me do that. Generate, which can keep track of the number of opening and closing parentheses, okay? So let's say I create a vector here, vector int, my bad, not int, vector string result, okay? Result. And that's it. Now, the result is where I'm going to be storing the values. Int number of opening parentheses right now I have is n, number of closing parentheses I also have is n, right? When you're starting, both the values will be same. Now, what you do is you call this generate parentheses helper function, which knows about result, which knows about number of open, which knows about number of close, right? And which also, I don't think it's required. So let's keep it this way, right? Let's keep it breezy. Or we need one more thing. We also need string so far. This is to, store the temporary string which we have created so far, right? You know that we are creating temporary string. So yes, we'll need a string here as well. String so far. Okay. So this function will do the work for me. Now I'm going to write it here. String so far. And then you have vector string result int open int close. Something is wrong here. What's that? The thing which is wrong is that I'm passing result by value. I should pass result by reference. Otherwise, it's gonna come and it's going to take the value. Also, I can pass string as a reference as well, right? I can keep on pushing an element at the end of the string and I can keep on popping the element, right? So that's what I'm going to do. Okay. Now, what is the terminal case? I told you that there's going to be two things. One is the base case and second is next recursion, correct? So what's the base case, my friends? So there's going to be two base cases. One is if open becomes greater than close, what will happen, my friends? You say that, hey, this is the case where you have violated the condition. This is the case where the string formed is what? Where the string formed is unbalanced. Oopsie. Correct? Next case is what? Else if open is equals to close. In fact, open is equals to 0 and close is equals to 0. Correct? This is the second case. We are anyway writing return, so don't need to write else. Now this is a happy case, right? This is the case where we have used all the opening parentheses. I mean, मेरे words को बहुत ध्यान से सुनो. This is the case where we have used all the open parentheses and we have used all the closing parentheses as well. Correct? Right, my friends? Okay, Ji. So this is the case in which I have used all the opening parentheses and I have used all the closing parentheses. It's not unbalanced. That means this is definitely a solution. So I'm going to do is result dot push back what? String so far. Our work is done. And let's do a return. Right? And let's do a return. After that comes the case where I have to figure out, comes the case where I have to figure out the next recursion, right? So what are the different values of next recursion, right? Oh, my bad. So from here, there are only two possible conditions, right? So if, or you can do an else if, it's up to you. If, so what I'm going to do is, I'm going to do string so far. I'm going to first add an empty parenthesis there, right? Open empty parenthesis there. Or one easy way to do that is let's do a pushback. Okay. String dot pushback. It's going to take a character, so I'm going to give it a character. So this is a pushback, and I'm going to do a popback as well. So I'm going to do a backtracking now. Okay. So instead of a pushback, I'm going to do a popback, right? And in here, I'm going to call my generate parentheses function again with string so far, the string updated, right? The result, the open minus, I have used one open, so it's going to be open -1, and then close, right? This is what I am doing, right? Since I did this thing for open, I have to do the same thing for what? Close as well, right? So once I have done that, let's do the same thing with close. And this time, make open is equals to close -1, correct? Correct? And I'm going to do one thing is, I'm going to return result over here, right? That's the only thing which is left, right? So here's the result. So this particular thing, this particular code which I have written, this is backtracking. So what I did was I created something called string so far. Now that string so far is empty, Let's create open is equals to 3, and let's also create close is equals to 3. So these are the empty things which, these are the starting variables which I'm starting. Okay. So look at the code. Can I paste this code? It will be nice if I can. I wonder if it will come there. Oh, but we'll see. Oh shoot, it did. Let me see if I can shrink it down. It's not happening. Just a sec. Okay, let's try to explain it this way. So first we did was we checked whether the open was greater than close, right? In this case, it becomes unbalanced. So the first case is not happening. Then we check whether open is equals to 0 and close is equals to 0. That is also not happening. So what happens is we first try to push. What we do is we first try to push an empty. We first try to push an open parentheses and then we pop it out. But between that, we also gave a recursive call. Correct. So think about it this way. Okay. So this is one function call going on. Consider the workspace of this function call here, right? And the value which is here is this empty 0, empty, my bad, 3 and 3, right? And what we did was we appended a value like that and we made a call. Now when the call was made, what were the functions which were passing? An empty. This time open become 2 and 3, correct? Again, the same function thing. We are when we, my bad, it's not closing, it's first it's opening, right? Yes, so first it's opening. So open is there, we append one more time. The next function call happens. This time there are two function calls with 1 and 3. We append one more time, right? And we do one more call. This time we have 3 open, 0 number of open and 3 number of close, correct? Now, can I do this one more time? Can I do this one more time? Answer is no, right? Because open has become less than 0. Open has become less than or equals to 0, but close is not. So the only thing which I can do here, is add a close and not just open, correct? And the function call goes next. This time it is, right? And then there is 0, 2, right? Again, we cannot press open because there is no open. So again, one more close. Right? Just press it one more time and you'll have 0, 0. This condition will come at one point of time. This condition will come. And at that point of time, we'll just push this to result. But when I move back, when I'm doing a backtracking, what I do is I remove this last character which I just inserted, and I try to insert an open closing parenthesis there. One more thing which I want to add here is, which right now this code will fail in one condition. What if open becomes less than 0 and close also becomes less than 0? And that condition is if open becomes less than 0 or close becomes less than 0, what does that tell you? That means I have already used the number of characters, right? So this should not happen. This, my friend, should not happen. Okay, so this work is done. Let's make it a little more clean. I like it, the else if thing. Else if both the conditions are true, and in the last else statement, let's write else if, just making sure that the code is coming inside here only when the things are right. In this case, just pull everything inside it. Okay. So this is going to make sure that my code is sane and it's not going out of memory at any point of time. Let's jump to the second problem. Okay. I'll not be solving this one. I'll just be showing you around. Okay. I'll just show around the same kind of problem. Okay. So help me solve this problem. This is quite a common problem which I think you might have seen. So what we have is, we have a simple this is the old style phone, okay, and the name of the problem is letter phone keypad, something like that. So what this says is that you have your old button wala phone, okay, and the button has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. What? Not 0. 0 is already done. So I think it's hash and it's star. Okay. Okay. So one thing is, whenever you had to write a text to somebody, right? Whenever you should text somebody, the keys like this two had some characters written at the bottom. For example, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay. So here's the question, my friends. So the question is that let's say I type the number 2, 9, 8, 3. Let's say this is a random character, right? Now when I press 2, 2 can mean A or B or C. Is that right? So this time it's not given how many times you press 2. I mean, if I press 2 one time, it just means one A. But if I press 2 times, it's gonna be B. And if I press 2 3 times, it's gonna be C. But in this question, it's mentioned that the number of times you press the key is not given, only that the key is given, that hey, this key was pressed. What can be the possible character the user meant? Okay, so 2 can mean A or B or C. We don't really know what that is. For example, 9 can mean what? 9 can mean W, X, Y, Z, right? Similarly, what can 8 mean? 8 can mean T, U, P. And what can 3 mean? 3 can mean D, E, and F. D, E, and F, correct? I don't really know what the user wanted, right? So so I basically want to get the list of all the possible characters the user could have wanted. For example, it can be A, X, T, E. It can also be C, X, T, E, correct? It can also be A, X, V, E, correct? But it can also be C, Z, V, F. C, Z, V, F. So now I think you'll be getting the question. So you are given an input as a number, this kind of number, and I want you to return me all the possible combinations which can be created like that, right? All the possible combinations which a user could have made. So again, same concept. I'm not going to code this one. I mean, probably code if you guys want to, but mostly I don't want to. Okay. So let's start with the possible key, right? So again, let's start with something called string so far, right? And let's keep it empty. Now what we do is we have an input, which is, let's call it IP 2983. Okay, let's say this is the input given, and you know the start value is 0 and the end value is, let's say, the size of this one, which is 3. Okay, this is the input which is given to me. Now I come to the first character. This is 2983. I come to the first character, my friends. What could 2 mean? And I have empty string right now, right? So 2 can mean A or B or C, right? So let's try to add A here. Okay, so A, I put it here, B here, and C here. So the string so far has become A or B or C. I don't really know which one, right? Let's just say it's A. Now, if it is A, what's the next key? The next key is 9, right? So my start becomes 1 because now I am at 9. Now I try to add the next value, right? So for 9, I know the value is W, X, or Y, or Z, right? So I make AW, AX, AY, AZ, right? And the value of start becomes 2. So I come here again. What can 8 possibly mean? 8 can mean TUV, correct? So it will be AWT AWU and AWV, and same for these cases as well. I've just not written so that it does not get bloated, right? So I keep on doing it till I get the last character, and by the time the start value will become what? End, right? In fact, start value will become 4. When start value become 4, I know that I have a 4 character sequence already, right? And at that point, I know I'll just push the result, push the string so far created in the vector, just like previously, just like I did last time. I'm going to do exactly the same thing. Let's try to revise this code here. Okay. So first is the base condition, right? Base condition क्या होगी? Base condition is अगर आपका open close से बड़ा हो गया है, that is my base condition, correct? यही है ना base condition. The moment your open or the moment your start becomes bigger than end, in this case I know कि भैया अब मेरा end आ गया है, मैंने सारे characters जितने भी मैंने keys press की थी, सारी keys को मैंने use कर लिया है. In that case, what I'm going to do is I'm going to push result. I'm going to push string so far in my result, right? And I'm going to return from here. Let's just make it start and end. ठीक है? So बाकी सब चीजें exactly same रहेंगी. देखना अपन लोग क्या changes करते हैं. ठीक है? इसकी जरूरत नहीं है, ये इसकी अपने को कभी जरूरत नहीं पड़ेगी. Else condition में आते हैं. In fact, else condition में आते हैं और अपने को ये if नहीं चाहिए. अब यहाँ पे अपने को यही बैकट्रैकिंग लिखना है, राइट गाइस? इसी तरह से बैकट्रैकिंग लिखना है. बट अब मुझे ये पता करना है कि यहाँ पे पहले तो मैंने ओपनिंग पैरेंथेसिस डाला था, राइट? फर्स्ट आई वाज यूजिंग द ओपनिंग पैरेंथेसिस एंड क्लोजिंग पैरेंथेसिस. नाउ आई नीड टू फिगर आउट कि इस पर्टिकुलर की का मीनिंग क्या है, राइट? सो वील हैव स्ट्रिंग इनपुट एज वेल. करेक्ट. अब char digit pressed is equals to what? Input start, right? For example, agar main, if I am at 2983 and the value of start is equals to 0, right? If my input is equals to 2983 and start is equals to 0, what am I going to get in the digit press? So digit press is going to come as what? 2, correct? It's character 2. You just wrote 2. It's not 2, it's character 2, right? So now we have to figure out कि 2 के corresponding क्या बनता है, correct? वो अपने को नहीं पता है. तो एक काम करते हैं, एक map बना लेते हैं. I'm gonna create a map here. That's right. In fact, I'm gonna create a, I think just a vector will do. Let's call it dial pad, right? If a user press 0, I do nothing. If a user press 1, I do nothing. For when a user press 1, I'm going to return ABC. When a user press 2, I'm going to press DEF. I'm going to write GHIJKLMNOPQ RSCUVWXYZ. अभी यहाँ से करते हैं, ठीक है? So it's going to start with 0 and it's going to end at 9, right? So this is the map. Okay. Now, if user presses 2, it should mean ABC for us, right? So I'm going to write string possible moves is equals to dial pad digit pressed minus 0. So this character is an input, right? If I had just given this, what would have happened? It's going to convert it into an ASCII integer. For example, if the value of 2 is, let's say, 66, I don't really know what the value is, but let's just say the ASCII value of 2 is 66, is going to keep asking dial pad for 66. That's not what we want. We just want 2. So I'm going to minus 0 from it just to make it 2 minus 0 is equals to exactly. So it's going to be overflow, index or overflow. That's not what we want. So we have string possible combination. Now string possible combination, what does this value contain? It contains ABC, right, my friends? It contains ABC. So I'm going to, so now I know what's the different values here is gonna be. So let's do one thing. For int I equals 0, shoot, possible moves dot size, right? because I have to include every single character, right? I have to check for A, I have to check for B, I have to check for C, right? So I'm going to copy this thing. I'm going to copy this thing, and I'm going to put it inside this, right? And now what I'm going to do is, let's put your input here. String so far result. Okay. Now what am I going to push inside? I'm going to push inside possible moves I, right? And I'm going to get rid of this one. This is not open. This is start and end. So earlier we knew that we can only input either an opening parenthesis or a closing parenthesis. This case we did not know, so we had to find it out by getting the value from map. Now I have to insert first A, then B, then C. So I'm running this loop 3 times. Every time this loop will run, it will first push A, then it will push B, then it will push C. Then it will go to the recursion step. After that, it comes back and it's going to do a backtrack. I mean, it will remove the last character. For example, if A was pushed, it will remove A so that B can be inserted. And it's going to do the same thing again and again, right? Is this clear, my friends? I'm going to change the name now. Letter combinations. So what this loop is doing, my friend, it's actually, so what earlier hum log kya kar rahe the? We were trying to first insert an opening parenthesis, then go to the recursion and then remove the parentheses again. Then insert the closing parenthesis, then remove, go to the recursion step, and then finally removing it. I'm doing the exact same thing here, right? So I told you that I have to insert A, B, and C, right? A, B, and C in the string so far. How can I do that? The way to do that is through recursion. So first I inserted A in the string so far, correct? So the string so far, which was empty in the start, what it is going to do? It's going to become A, correct? That's right. So your string so far becomes A. Once it comes back, you want to remove the string so far, A from string so far, so that it becomes empty again, so that the next time this loop runs, it can insert B, right? And this string so far, my friend, will become an input for letter combinations in next permutation, right? So there is a bigger cousin of this problem. I'm not going to solve this. I'm just going to tell you about it. So the next third problem, which I'm not going to solve, I'm just going to talk about it. It's called permute. What does permute means? It means that, let's say I have given you a string str, okay, and the value of string is, let's say, A, B, and C. This is the input which is given to you, my friends. In the output, what I want is all the different permutations of A, B, C which can exist. Acha, there is one more thing. It is also given that the characters are unique. Okay, so these two things are given. First, a string with the constraint that the characters of the string are going to be unique, no repetition, no duplication. Okay, and in the output, what I want from you is all possible combinations of A, B, and C. Right? What are the possible combinations? It can be A, B, C. But if I swap the value of B and C, it can be A, C, B. What if I swap A and B? So it can be B, A, C, or it can be B, C, A, or it can be C, A, B, or it can be C, B, A. Correct? Correct? So these are all the possible combinations. It's actually 3 factorial. How much is it? Yeah, 3 into 2, 6. Yes, 6 possible combinations. So I just listed out all the 6 possible combinations. Right. So I've listed down all the 6 possible combinations. I'll give you a string and you'll return me what? A vector again. You'll return me a vector of what? You'll return me a vector of string, my friend. Is that clear? So I'm not gonna solve this problem. I'm gonna give it to you as a homework. Okay. So solve this problem as a homework. Then we'll move to the next problem. It's also something which I'm not gonna code. I totally forgot what I wanted to give. Yes, I remember now. So the next question is power set. What does power set means? Now this is going to be an interesting problem because you'll have to do some extra memory allocation. Okay, So this becomes an interesting problem, and I want you to spend some time on it. Chaliye, so the problem is that I have given you a set. I have given you a set. When I say set, no duplicates again. So set can contain 1, 2, and 3. Let's say a set contains S contains 3 elements, 1, 2, and 3. What I want from you is that you give me the power set of the set X. Do you know what a power set is? So for those who do not know, power set is a set of all possible subsets of S. What's that? It's quite mouthful, right? So let's try to think about this way. Let's create all the sets with just one element. This is an empty set, also called null or void, whatever. Okay. So look at this. Look at this output. So this is the power set. Okay. This whole thing is a power set. What does it mean? So I try to create all possible sets from the given elements, right? I try to consider one element at a time. I try to consider two elements at a time. I try to consider three elements at a time. Hell, I even try to consider null element at a time, right? So no element at a time, one element at a time, 2, 3. I mean, basically the size of n, I try to consider all of them, right? So this is the power set. So given a set S, you return me this power set. Of course, it's going to be a vector of vector. So that's why I said it's going to be an interesting problem, but not quite different from what we have done. So you have to give me a vector of vector if I provide you this input as S. So the third problem, again, let me tell you. So you are given a string S, which can contain, I don't know how many characters, but the constraint is given that the characters are going to be unique. Okay. If the characters are going to be unique, the ABC, number of possible combinations you can get by swapping the character in place. So it can be ABC, it can be ACB. I mean, if I swap these BC together, it can be ABC or ACB. If I swap AB together, if I swap A, what I did here, BAC, sitcom, I've tried to swap A with B in this case, and I have tried to swap, I've tried to make it BC in this case. Oh well. And in this case, I have tried to swap ACB and ABC. Yeah, got it. Yes, correct. So basically, I have tried to swap multiple values with multiple values, right? And it has given me this possible list, right? If I tell you that the value is A, B, C, D, there's going to be 4 factorial type of different combinations. It's 24, right? So it's going to be a lot of combination. You have to return me all the possible combinations. So let's jump to the next interesting question, the fifth one. I'm going to start with an easy one. Okay, let's jump to the grid questions, and those are the interesting grid questions. So here is a grid. Okay, I am creating a grid. So now I'm going to talk about some problem. It's a famous problem, rat in the maze. So what rat in the maze problem says that, let's say this is where my rat is. This is the exit. Chaliye, so this is rat and this is the exit. So this is rat in the maze problem. Now you're given a rat and the exit. A rat can move in 2 directions only. It can move in this direction or it can move in this direction. Okay. So rat can easily move from here, 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 and reach the exit. But the problem is that there are some blockers which rat cannot jump. Okay, so there are some problems, or there are some blockers which rat cannot jump. So I need to figure out whether a rat can reach the exit point or not, right? So I'm going to give you an input. That input will contain a vector of vector. Let's say a vector of bool. Okay, it's called matrix of size n cross n. Okay,